Hello everyone, this is BALLULLAYA from Canada Engineering College. So in today's today's video, we will learn about linked lists. Okay, that is linked list. So in linked list, we will learn about application of linked list. Okay, so in application of linked list, we had two concepts. One is polynomials and another one is sparse matrix. So in this video, we will discuss about the polynomials. So what exact in polynomials we will be studying. So here in polynomials we will see how do we implement a linked list, how do we implement a how do we implement a polynomials using the linked list. So this is what we are going to learn. Okay, what are polynomials? In general or mathematically, what are polynomials? A polynomial is a combination of coefficient and exponents. Okay, so these polynomials are nothing but equations. Okay, these are nothing but equations. So equation we tell as a polynomial, and that equation will have the coefficient and it will have the exponent. So we represent a polynomial, each term as a node. So when we represent this polynomial in a linked list, each term of a polynomial we take it as a node. Okay, yes. So here if you take this one example 6x cube, it is a single term, correct? It is a term. Okay, so this term is taken as a node, taken as a node. Okay, yes. So here 6, whatever 6 is there, this is nothing but a coefficient. 6 is a coefficient, and to x to the power 3 is nothing but a exponent. So this is how we represent a polynomial. Now let us see in the next slide how do we represent this particular polynomial in a linked list. Yes, so let us represent a linked list. Let us represent a polynomial in a linked list. So for that, let us take one example of a polynomial. So let me take 6x cube plus 2x square plus 11x plus 1. So this is the polynomial. So we know that here there are total 4 terms. Here there are 4 terms. Means 4 nodes. Means 4 nodes in a linked list. So A is a pointer to the linked list, which is followed by a 4 node structure. 1 node, 2 node, 3 node, okay, and a 4th node. Okay, last node 1. Okay, so each node will have 3 fields. Each node will have 3 fields. Yes. Now here the first field is a coefficient and the second field is called a exponent and the third field is called a pointer to next node. Pointer to next node. Okay, yes. So this will be better. Okay, so let us start filling values in our list. Okay, in according to our given polynomial. Yes. So we have 6x cubed. So we know that 6 is a coefficient in the first term. So we write 6. And we know that 3 is a exponent. Okay, in our first term. So 3 is a. So this is nothing but a pointer, which is nothing but address of the next node. It can be any address. Okay. Next one is nothing but 2. 2 is a coefficient and 2 is a exponent here. Again, this is the pointer. Next 11 is a coefficient and 1 is the exponent, and this is again a pointer to the next node. Yes, x to the power nothing means it is x to the power 1 by default. Next is 1. 1 is nothing but x to the power 0. So here 1 is the coefficient and 0 is the exponent. So this is how we represent a polynomial in a linked list. Yes. Now how do we represent it logically? How do we represent it logically? So we take a structure. Okay, we take a structure. Since we know that each node has three fields, we have three fields. So we have three entries here. So one is int coefficient. Okay, this is a coefficient field. Then this is a exponent field. Second one is an exponent field. And third one is nothing but a pointer field. The pointer to next node. Okay. Yes, pointer to the next node. So we know that always the pointer to the next node, it is of type next node. Okay, so that is why we represent it that way. Okay, and since struct type polynode, it is a big name, we simply type def it, or we rename it. We rename it to p node. Rename it to p node. So this is the how do we represent it logically. Okay, so we have one more example here. So they have two equation. One is p1 of x and one is p2 of x. Yes, so that is one is p1, that's for first one, p2 for the second one. So 23 is a exponent here. Sorry, 23 is a coefficient here. And 9 is an exponent. So we have totally 5 terms. And each of the terms are represented here. Second one is 18 is a coefficient and 7 is the exponent. 41 is a coefficient, 6 is the exponent. Okay, and here we have 163 x to the power 4. 160 x to the power 4. So this is not 18 and 7 students. It is 163 and 4. Okay, next one is nothing but 3. Okay, because coefficient is 3 and we don't have any terms here, so that is why 0 is a exponent. Next one, you have 4 terms. Okay, so first one is 4 is an exponent coefficient, 6 is an exponent. Similarly 10 is a coefficient, 4 is an exponent, 12 is a coefficient and 1 is an exponent. Okay, yes, so that is how it works. And 0 is a, here 8 is last term, 8 is the coefficient and 0 is the exponent. So these are the nodes. So this is how you represent a polynomial in the linked list. Now let us see the addition of a polynomial. So this is just an example. So we have a polynomial here. Okay, so this is nothing but 6x square plus, that is nothing but your p of x is nothing but 6x square plus 7x plus 4, and q of x is nothing but 8x plus 6. So students, when we add this, we get 6x square plus 15x plus 10. Okay, so that is what they are showing here. Now let us see exactly how does we do the working of this addition of a polynomial in our next slide. Okay, so let us see in a linked list implementation how it does it exactly work. So let me write my polynomial here. Okay, because we may need space, no. So let me write it, p of x is equal to 15x 10, okay, plus 3x to the power 5 plus 10, and our q of x will be nothing but 10x a to the power 8, then 16x to the power 5 plus 5x square. Now let us see what is the answer for our r of x. So we can implement it a linked list, and let us see how does we add exactly. How does we add r of x, which is nothing but r of x is equal to p of x plus q of x is equal to, let us see. Okay, so let us do one this thing. So the first p of x has three terms there, so we need to do a linked list here, which is p of list. It is having three terms. Next is nothing but q of x. Q of x also has three terms. So next is nothing but r of x is equal to q of p of x plus q of x. Correct, no? So let us do the linked list for that over here. So let us see how to do add first of all. So students, we will have p pointing here. Let us fill the values first of p. So we know that 15 is a coefficient, 10 is exponent, and 3 is a coefficient, and 5 is an exponent, and 10 is a coefficient, and 0 is the exponent. And here we have 10 is a 10 is a coefficient and 8 is an exponent, 16 is an coefficient and 5 is an exponent, and 5 is an for the last term 5 is an coefficient and 2 is an exponent. Okay, so we know that initially, students, this is p of x. So of course p will be pointing here, and q will be this q of x, so we know that q will be pointing here. Okay, initially. So what will happen is now we are adding. Now what, why, how do we add exactly? We compare the powers, that is compare the exponents for adding. Compare the exponents for adding. Okay, if the bigger exponent term will be added to result, Okay, so we know that when we compare 15, okay, we know that compare the exponents of what you compare components, the exponents of, compare the exponents of p and q. Okay, yes. So we know the 10 and 8 we compare first, students. So we know that 10 is bigger. So our first this thing in r of x, our first node will have, you need 15, 10. Okay, yes. So next we'll continue this. Okay, for the next node. Now p is over. Now p will progress. So p, which was here, cut it there, from there, and p will come here. Again compare phi, p and q. Now we know that q is bigger because power of p, current p, is nothing but, power of p is nothing but 5, and but power of q is 8. Okay, power means exponent, both are same. So what you're supposed to do is nothing but, you have to copy q now because q is bigger, so copy q. So what you have there in q, you have 10 and 8, that is 10 is a coefficient and 8 is a exponent. Okay, then continue. So q, which was there here, will be deleted from here, and q will continue to the next term, q will progress to the next term. Now you have p and q here. Okay, when you have p and q here, yes. So this is null, students, because you don't have anything after it, so this will be null, remember. Yes, so p and q are same, students. Now both are having same. So when powers are same, you have to add. When exponents are same, add the terms. add P and Q, add P and Q. Okay, and so that is how you write the result. Okay, that is how you write the result. That is nothing but you have 16 plus 3, that is 19, and 5. Okay, yes. Now both P and Q will progress. Now both P and Q will progress. Okay, yes, to the last term. So now Q will be, P will be here and Q will be here. Okay, now now again comparison will happen. We know that Q is bigger, so Q will be copied. Q will be copied. So what do you have in Q? You have 5 and 2. That is 5 is an exponent, 2 is an coefficient. Now Q will be deleted from here and Q will go to null. That is Q is exhausted. Okay, now Q will go here. That means what? Exhausted. Yes. Next is nothing but, let us go to the, now whatever terms is remaining, students, that is P term. So that you need to copy. That you need to copy. So that is how you, right, that is nothing but 10 and remaining terms. So we have only P there, 10 and 0. Okay, and this is nothing but null. Okay, so writing inside the list, outside it's both null, it is same only, students. Okay, yes, so this is nothing but R. Okay, so this is nothing but R of X. Okay, yes, so even P will get exhausted from here, and finally your P will be here. Okay, now both the P and Q are null. So of course P and Q are null means the whole thing is done. Okay, so how do we write the result now? How do we write the result? Okay, so let us all remaining all these things. We'll just put it. We are done with that, no? So it's over. Yes. So we don't need anything this thing now. Okay. Yes. So it is nothing but P of x plus Q of x is nothing but 15 x to the power 10 plus 10. See the terms there in the linked list and write 10 with a coefficient 10 x to the power 8 plus 19 x to the power 5 plus 5 x to the power 2 plus 10. Okay, because exponent 0 here. Okay, which is nothing but x to the power 0. Both x to the power 0 is equal to 1. Remember that. Okay, so you don't have anything there. And x to the power 1 is equal to x. Remember that. Okay, so that is why we have x there. Whenever 1 is there, we have x. So that is how your working is done. Okay, that is how your working is done. This is how do you add the polynomials. So that's all we have, students. Okay, in our video. Thank you. Thanks a lot.